Tara, Melissa, and especially Teresa for everything they all do. Without them, we couldn't have pulled off this event. And thank you to Ricardo for taking care of all the complex technology for all the things, especially this event. And thank you to the invited speaker committee for working so hard to put this together. All the graduate students that participated in our speaker selection process and everyone participating in events today. Your participation is what makes all of this worth it. A quick reminder that we will be having happy hour tonight at McMiniman's at 5 o'clock, so please be there. And before I hop on my introduction, I would like to give a big thank you to Liana for coming all this way to share her research and expertise with us. It's so special to get to see you and talk to you. And speaking of research and expertise, Liana earned her bachelor's degree in psychology at University of Toronto, her master's in biology at Queen's University, and her PhD at the University of New England in Australia. She then did a postdoc at University of British Columbia, and she's currently a professor at Western University. Liana investigates how predator-induced fear impacts population, community, and ecosystem dynamics, along with the effects of fear on health, development, gene expression, and neural architecture in the brain. Her research uses large-scale field experiments to test the demographic and trophic consequences of behavioral, physiological, and neurobiological phenomena. So with that, I'd like to welcome Liana to OSU and invite her to begin her talk. Thank you.
Thank you very much. Thank you for the lovely introduction. And is this okay, the volume? And thanks so much to the graduate students for inviting me. It's such an honor and it's a real pleasure to be here. And I've had some great conversations already, and I look forward to talking with the rest of you today. It'd be great. And make sure you come out to the happy hour. And I would love to begin my talk.
Sorry, the browser is just not cooperating.
Could it be my computer?
I honestly don't know anymore. Give me 1 second.
This morning, Val took me to look at some bluebird babies, and we measured them. So she's right on top of the data collection. What do you reckon, Ricardo? Should we start? Want to use your computer? Or?
No, that works. Finally.
Thank you. Yeah, so today I will be telling you about predator-prey interactions, and I'll be highlighting the role that the fear of predators play in structuring populations and communities. Now, in their paper, Trophic Downgrading of Planet Earth, Jim Estes and colleagues describe what they call a paradigm shift that has occurred in ecology, stating that the loss of predators that we've experienced worldwide may be humankind's most pervasive influence on nature. And they say this because they've documented that when predators are lost, we get degraded ecosystems. We keep predators are intact or restore them, and we can have healthy ones. So clearly, predators have effects on every single tier of the food chain, right? Far beyond what we ever previously imagined. And so given the pivotal role that predators may play at all levels of biological organization, it is absolutely critical that we have a complete understanding of how predator-prey interactions work. But how do they work? And what on earth can account for this disproportionate effect that predators have throughout the food chain? Well, that's precisely what the ecology of fear is meant to answer. The ecology of fear concerns itself with quantifying the total impact of predators on populations and communities and to understand the mechanisms involved, but all focused on fear, that the fear of being killed affects the population growth rate through a reduction in fecundity and survival, that the fear of being killed can generate trophic cascades. And the mechanisms here are all expected to be behavioral, right, and long-lasting and powerful enough to scale up from individuals to affect populations and communities. And I will be talking about these three elements today. Now, the heart of predator-prey interactions is simplicity itself, right? It is all about food. And because predators kill prey for food, killing can certainly affect prey population numbers, right? And because predators are always prey of something else, killing can also have effects through the food chain. And indeed, killing represents the textbook view of how predator-prey interactions can work, right? And it makes perfect sense. I mean, this is a bird nest in an urban park in Victoria where we worked for many years. Now that cat has just eaten a nest full of baby birds, right? Which means 0 offspring produced for those bird parents thanks to that cat. Thanks to this hyena, that prey is no longer alive, right? From our work in South Africa. Now, precisely because predators are lethal, predators also scare prey. And the fear of predators has got to be one of the most powerful unifying forces across animal taxa, because for any predator-prey interaction is discrete and profound. It is either your ongoing life or your immediate death. And if you die instantly in a predator attack, your fitness instantly drops to 0, right? Worst thing in the world in Darwinian terms. And so all animals across all taxa have to do whatever they can to avoid these really grisly outcomes. And it turns out that all animals in all taxa do mount behavioral anti-predator defenses to avoid being killed. And while enormously beneficial on the one hand to keep you alive another day, you can imagine that this could be really hard on the condition of an animal, right? Because scared prey typically eat less, simply because you cannot have your head up looking for predators and your head down looking for food at the same time. So animals can either have their eyes forward and eat, but then they risk being eaten. Or you can have your eyes back and miss meals so as not to become a meal. It is a total trade-off. And because predator-prey interactions are all about food, then conceivably, just conceivably, predators may actually be having effects through 2 pathways, through killing and through fear. If predators do induce long-lasting anti-predator behavioral responses in prey, like eating less, that are powerful enough to affect the food of the prey further down the food chain. And because predators always scare way more prey than they could possibly kill, by not including fear, by focusing solely on direct killing, we may be underestimating the impact of predators. Right? It's possible, but how fear might function in nature is not very well understood, especially with regards to wildlife. And so that's what Mike Clinchy and our students do in our lab. We study fear, which means we scare stuff. We've gone to many different places in the world and scared all manner of animal, from birds and bears in Canada, cougars in California, various wildlife in various African countries. And I'll tell you about a little fraction of this work today. Now, just so you know, the reason I'm calling this fear is because this is how Darwin recognized it. Of course, animals on the Galapagos Island evolved without humans out there to kill them, right? And so by the time Darwin got there, he was really struck by how tame all of these animals were, stating in The Voyage of the Beagle that all of them are often approached sufficiently near to be killed with a switch, and sometimes, as I myself tried, with just a cap or a hat. The fear of humans must be an acquired instinct. Fear has long been recognized. Now, to directly test for fear effects, it is absolutely critical that we conduct manipulations. We can often see when predation happens. It's readily quantifiable. But what about this animal? Is this animal fearful? Kind of looks all right. And it's not like we can pull out any instrumentation, right? Like Gary Larson's Fearo sensor here to gauge how fearful this animal is. That would be great, but you can't do it. We need to come up with other techniques. And so quantifying fear effects in free-living wildlife can be enormously challenging. For one, to unambiguously identify fear effects, it's often helpful if you're able to eliminate direct killing, isolating that fear pathway so that any effects you see on populations or communities can be ascribed to fear alone. But these things are hard to do in wildlife. But the good news is that we do have something to go on, because such experiments have been repeatedly done in small, closed, mainly invertebrate systems, where researchers typically isolate the fear pathway by rendering their predators toothless, gluing chelae together, ripping out stabby mouth parts so that the predator can wander around and scare the prey but can't actually kill them. Now, meta-analysis of this large body of work indicates that fear effects on populations and communities absolutely do exist, at least in these systems. Now, the challenge here is that our systems are usually not small and closed, right? Also is the challenge of eliminating direct killing. It's not like we're going to be taking our carnivore here and ripping out its stabby mouth parts or gluing its mouth shut or doing any of those other things that the invertebrate people are able to do. We have to do it differently. That's the next challenge. How are we going to manipulate fear to experimentally do our tests of population and community impacts? Because unlike those animals in small containers, right, ours can go wherever they like. And so our solution to this logistical difficulty has been to use sound, because sound, like our animals, really travel, and it fills up space like it's doing now, hopefully, virtually guaranteeing that the prey will be exposed to it. And sound also has the value of signaling that the predator is present then and there. I better be afraid if I don't want to die. And we've learned over the years how we can use sound over the time scales that make it relevant to populations and community, because the amount of sound that we add is enough to be a successful manipulation, but it's low enough to avoid the habituation that you would normally expect over such long time frames. For our first series of experiments, we wanted to test whether or not fear itself can affect the population growth rate in free-living wildlife. So to do so, Mike Clinchy and our students, Asia White, Merrick Allen, and I conducted a multi-year fear manipulation on populations on the west coast of Canada. The main results are published in these two papers. Now, our experiment was conducted on wild free-living song sparrows. And here, we comprehensively measured the total impact of fear on all of the demographic variables that make up the population growth rate. We started by counting eggs laid, and then we monitored the survival of those eggs through each of these life history stages. Now, to eliminate direct killing, we rendered our predators toothless. Mammalian predation was eliminated by encircling all nests here with electric fences. Large bird predation was eliminated by covering all nests in the manipulation with seine netting. Now, the holes of the net here were large enough so that the parent birds could get in and out without any troubles. But the large birds can't get in. So here we have a claw. There's the net, right? Stabby mouth part. So that predator, though, cannot get to those offspring to eat them. Then we manipulated fear using sound. We deployed speakers in our various chunks of forest. It goes on for 4 months at a time over breeding seasons, playing either predators for some populations, non-predators for others, over our 16 hectares, replicated over 3 years, which actually gave us 5 years of data because we were also interested in fear across generations. And what we found is that fear leads to 10% fewer eggs laid. 11% fewer of those eggs survived, leading to 19% fewer offspring at the nestling stage. 21% fewer of the nestlings survived, so there were 37% fewer kids at fledge. And then we followed the fledglings around with radio tags, found that 26% fewer of them survived, indicating that fear leads to 53% fewer juveniles by the end of any given breeding season. Then in the next breeding season, right at the beginning, we go around, we find the now adult recruits. And one thing you can see here is that overwinter survival does not differ between the playback treatments, which means that overall, fear leads to 53% fewer recruited offspring. That is the cumulative cost of fear on offspring production. A couple of other things about this is that you can see that relatively small changes really accumulate over life history stages, leading to that big drop in offspring production. And finally, it's really survival during the period of parental care that sets the ceiling on the number of offspring that are available to recruit. And I'll be coming back to parental care in a tick. Now, the population growth rate is based on a really simple equation. It is the number of adults that survive plus the addition of new recruits. That gives us lambda. Putting our lambda values together, we find that fear itself leads to 15% reduction in the population growth rate. And then taking our lambda values here and projecting it out over time, we find that fear itself can reduce wildlife populations by half in just 5 years. And that's pretty remarkable. But wait, because we actually discovered more about this. And what we discovered is that the total impact of fear was even greater than what I just described due to an intergenerational effect that we detected. Because our recruits were permanently damaged by fear. And we know this because recruits that had previously been reared with predator playback vocalizations sang fewer songs than those who had been reared with non-predators. And the relevance of this is that song number is well known to predict survival and reproduction in this species, which therefore can be expected to exacerbate those population level impacts that I've been telling you about. But by how much? Well, to estimate that, we took our 7 songs sung by our predator playback recruits here and figured out the associated reduction in survival and reproduction that would entail. And putting that together, our lambda goes from 0.91 now down to 0.85, meaning that fear itself can now reduce wildlife populations by half in just 4 years. Now, the mechanism driving all of this, the agents of all of this, are the parents. It's all about parental behavior. And we have really good evidence that reduced feeding by frightened parents causes the reduction in offspring survival. Scared parents certainly feed their offspring less. Their offspring, therefore, are in poor condition and so less likely to survive. We also have really good evidence that reduced feeding by frightened parents causes that intergenerational effect. Again, scared parents fed their offspring less. And we also know that reduced parental feeding impairs brain development, because in another experiment that we did in the lab, we were the song sparrow parents, and we hand-reared song sparrow nestlings, some of which we fed at a slightly reduced rate. And what we find is that less feeding of offspring at the nestling stage leads to smaller brains of those offspring by the time they're juveniles. And then we also know that impaired brain development is associated with impaired learning ability, because in this experiment here, we find that adult recruits with the smallest brains are also the ones that sing the fewest songs. And so putting these elements together then, what it suggests is that fear-induced reductions in parental feeding damages permanently their offspring, and then the poor survival and reproduction of the recruits that ensue has those further repercussions on the population growth rate that I was telling you about. We also have great evidence that reduced feeding by frightened parents reduced their fecundity. Now, I have to say that when we proposed this idea some years ago, we were told that it was absolutely preposterous. Preposterous is what they said, like literally. Because the textbook view of fecundity is that it is all about the bottom-up food supply. And indeed, when we ourselves food supplement song sparrows, as we did for about 4 years, we too find that it's those non-food supplemented females, those hungry females that lay fewer eggs. But now we know that predators affect egg production too. We've done 2 completely different sorts of experiments, a couple using playbacks here, another using a totally different technique headed up by our student Mark Travers in collaboration with Tony Williams, which consistently show that scared females lay fewer eggs. Now, the similarity in the pattern amongst these manipulations suggested to us that, well, maybe like our non-food supplemented females, maybe our predator females are hungry too, and that the demographic consequences of being scared is such that it actually looks like limitation by the bottom-up food supply. But it's not, it's completely predator-driven. Well, to test that, we went back to this Travers et al. Experiment, the key here being that all birds in that manipulation were given supplemental food. So this effect here on egg production cannot be due to the bottom-up food supply. It just can't. That is unlimited. This is a fear effect. And we were able to directly test whether reduced feeding by frightened parents could explain it using stable isotopes, because the supplemental food that we use contains a delta 13C value that's radically different from anything else in the environment. We did this with Keith Hobson. And what our delta 13C values told us is that females that experience high predation risk ate way less food compared to low-risk females who just gobbled up the supplement, indicating that frightened parents absolutely do eat less food, even when the bottom-up food supply is unlimited for everybody. We also showed in that same paper that females that ate less food gained less fat and were in poor physiological condition compared to the gobblers up here. And of course, we know from our manipulations that females that experience high predation risk also lay fewer eggs. Okay, so fear does affect wildlife populations. And I've been talking about how this is mediated by foraging behavior. But what I want to do now is talk about a different type of mechanism. And to do so, we need to take one step back from behavior, and I need to tell you something about fear in the brain. Because it stands to reason that before an animal can mount an anti-predator behavioral response, as all animals do, that all animals must first possess a memory of what is fearful. And because you only have that one chance to learn, fear memories literally have to form instantly, and they have to be permanent, at least long-lasting, thereby virtually transforming the brain. Now, this does turn out to be the case whether we're talking about the simple systems of snails that have like 3 neurons, right? But they're still able to form long-term memories, but only when they live with predators. This is also the case with the more complex brains of humans. Now, for humans, we do know that the neural architecture of the brain can be permanently transformed by fear. And this is perhaps most clearly seen in post-traumatic stress disorder, where a human being experiences a life-threatening event. It might be combat, it might be something else, but then can experience those really powerful downstream effects on behavior, on physiology, long after you're out of that situation. Why? Because the memory of fear continuously triggers. The memory has formed, and it is not now long-lasting, if not permanent. So to better understand the etiology and so treatment of PTSD, biomedical researchers have long been using animal models. In this case, they would take a lab rat, foot shock it to induce PTSD-like symptoms. Now, a more recent technique has been to show the lab rat a predator cue. So here, the animal is not experiencing any physical pain, but it is experiencing something that is life-threatening. It's a completely psychological stressor, and so well emulates the etiology of PTSD. And what these people are finding is that even brief exposure to some predator cue does lead to lasting effects on gene expression and the neural architecture of the brain, just like we see in PTSD. Now, one reason people know these animals are fearful is because one of the areas of the brain that really lights up in terms of gene expression is the amygdala, which is sort of thought of as the gatekeeper of the fear network in the mammalian brain. This is where we often go to measure fear. Now, all of that work, though, has been done on animal models in the lab. But when you think about it, wildlife are faced with imminent death every single moment of every single day of their entire lives. You can never really let down your guard unless you want to become dinner. And so it stands to reason that if even brief exposure to a predator cue can lead to lasting effects in lab rats, surely we're going to see the same sorts of effects in the brains of wildlife. And importantly, that this might help us better understand how we can then see those long-lasting, powerful downstream effects on behavior, on physiology, on populations that I've just been talking about. It actually all starts with those transformational changes in the brain. Well, whether or not fear can cause PTSD-like changes in the brains of wild animals has largely been unstudied. And so some years ago, Mike and I began a research program to study it. Our procedure is to conduct experiments on wild animals that are totally modeled on the laboratory rodent studies of PTSD. And we've done this in progressively more natural conditions. We started with chickadees in small cages in the lab, then we took it outside, working on cowbirds in semi-natural conditions, and then free-living deer mice and voles in BC and Ontario. And for today, I'm just going to tell you about this first set of experiments just to give you a flavor. So here we were interested in the short and long-lasting effects of predator exposure on the fear network. So we brought our chickadees in from the wild, put them into the lab, put them into acoustic isolation chambers, and they heard either non-predator or predator vocalizations. And then the chickadees were put onto rooftop aviaries together where they just hung out for a week without any exposure from us. This is all based on the animal model protocols. And then we looked for gene expression. We basically counted dots in the amygdala. And we looked for this both in the short term, so right after exposure, and in the long term as well, so 1 week after we had presented them with the predator cue. And what we find is that fear does leave a long-lasting imprint on the brains of wildlife. Those chickadees attended to the predator sounds in the short term, and they retained a long-lasting memory of fear in the long term as well. 1 week after exposure, we were still able to pick up this heightened sense of danger, right? This signature of danger. We also find that the memory of fear is retained in their anti-predator responses. 1 week after exposure, we brought the chickadees down from the rooftop aviaries and presented them with a conspecific alarm call. And those who had heard predator sounds 1 week previously basically stopped moving and froze compared to those who had heard the non-predator sounds. Again, indicating an ongoing, an enduring heightened sense of danger. Okay, so fear affects populations. I've talked about mechanisms. Now let's turn our attention to see whether or not fear can generate a trophic cascade. Well, for this, we went back to our Gulf Island ecosystem because historically, we used to have all kinds of carnivores, large carnivores, cougars, bears, and wolves, which of course love to eat medium-sized carnivores, like this raccoon, which loves to eat intertidal life. So by being in the system, theory would say that these large carnivores keep the raccoons in check, so to speak, thereby having a positive benefit on the raccoon's food further down the food chain. But like many other ecosystems all over the world, these large carnivores have been exterminated by humans. This happened about 100 years ago for us. And so what we want to know then is, in this environment, has the loss of fear had a really big positive effect on raccoon feeding, leading to a big negative effect on the raccoon's food further down the food chain? All of this work was headed up by our brilliant PhD student, Justin Sirachi, and we started here with a natural study. So in this environment with no large carnivores left, what we find is that what this means for raccoons is that they can constantly eat. We quantified it. They spend 59 seconds of every minute with their head down, under rocks, flipping them over to look for food, and only 1 second of every minute with their head up. That is diagnostic of a fearless animal. And constant eating led to a 90% reduction in intertidal crabs, a 94% reduction in intertidal fishes, a 38% reduction in red rock crabs on islands with raccoons versus islands without raccoons. So what we want to really nail now is whether or not the loss of fear per se is the thing that has caused this trophic cascade. Well, to find out, we restored just the fear of large carnivores back into the system. We looked at the effect that that had on raccoon feeding and the effect that that had on the raccoon's food further down the food chain. So to experimentally test our fear of large carnivore cascade in our model mesocarnivore here, we took our speakers out, put them out along these different chunks of shoreline. They broadcast either barking dogs or barking seals, dogs being the only large carnivore left in the system. This goes on for 30 days at a time. Then we reverse the treatments, replicated on 2 islands over a couple of years. And what we find is that barking seals does lead to constant feeding, just like we see in our natural study. Barking dogs leads to 66% less feeding because raccoons spend less time on shore and less time foraging when they actually do venture to shore, just because they think a large carnivore is around. And certainly less feeding by our frightened prey benefited their prey. Our fear manipulation led to a 97% increase in intertidal crabs, an 81% increase in intertidal fishes, a 61% increase in red rock crabs. So yes, indeed, fear of large carnivores does generate a trophic cascade. Fear of large carnivores reduced mesocarnivore foraging, which then benefited the mesocarnivore's prey, which then had cascading impacts on a competitor and prey of the mesocarnivore's prey. And by comparing our fear manipulation too with our natural study, you can see that restoring fear does actually seem to help restore ecosystems, which is why scaring animals shitless can be really good for the environment, right? Fear certainly has its uses. But what I want to do now, though, is talk about the effect that another kind of predator might be having out there. And that predator is humans. Because recent worldwide analysis shows that humans kill medium, large, very large mammalian in addition to avian prey. Basically, it seems that if it fits on a dinner plate, it's fair game at much higher rates than non-human predators do. So much so that we are described as having a unique ecology amongst predators because we are super lethal. We are a super predator. And so all along, right, throughout this talk, I have been telling you about the classic view of a food chain and how fear operates through the various levels. But what we've been completely missing all of these years is the perception that wildlife may have of humans as predators and the effect that this may be having throughout the various levels of the food chain. But whether human hunting and persecution of wildlife has actually caused them to fear us, and whether it has any ecological consequences, has largely been unstudied. And so we have been studying it. For our first manipulation, we experimentally tested fear of humans in a model mesocarnivore. So here we worked on European badgers along with Dave McDonald. Now, in the UK, where this work was done, badgers do not need to fear any native large carnivores anymore, right? Because humans exterminated them well over 500 years ago. But maybe they have more to fear from humans anyway, because even though badgers, like a lot of mesocarnivores, they live in a completely human-dominated landscape, and they have done so for millennia. You think, well, they live with us, right? Surely they love us. Well, maybe not, because badgers, like other mesocarnivores, are hunted and persecuted. And this too has been going on for millennia, and it goes on to this very day. So in the end, Mike and I did a manipulation with David that demonstrated that fear of the human super predator way far exceeds fear of any other large carnivore in our model mesocarnivore system, totally consistent with humans being far more lethal. So specifically, fear of humans maximally affected their latency to feed compared to bears, dogs, wolves, sheep were our control. For our next playback manipulation, we experimentally tested fear of humans now in a large carnivore, cougars, working with Chris Wilmers. Now, GPS collars allows us to find the cougar's kill. It's usually something like a deer. We tether it to a tree, and then we set up our automated behavioral response systems, or ABRs. We developed these in our lab, and they consist of a motion-triggered camera connected to a custom-built speaker. The idea being that when the cat comes back to feed on its kill the next night, triggers the camera, triggers the speaker, which plays a 10-second vocalization of either humans talking or frogs peeping. What we find is that large carnivores fear humans, and they certainly do eat less as a result. Cougars fled when they heard humans. They took a lot longer to return to their cache after hearing humans, such that over a 24-hour period, cougars fed about half as much at their kill just because they thought that humans were around. And the responses here are really quite remarkable. I'll show you a couple.
Because the grand jury rendered it correct.
Right? Humans play and they are gone. For our next manipulation, we scaled things up really big. And we experimentally tested whether fear of humans can lead to cascading effects in a carnivore community, large and medium. For this, we put our long-term speakers out in a grid in various chunks of forest here. And they broadcast either humans talking or frogs peeping. This went on for 5 weeks at a time. Then we reversed the treatment. It was replicated on 2 grids, 1 kilometer square each. And what we find is that fear of humans over on this side, it causes avoidance and cautiousness in our large carnivores. It caused elusiveness and reduced foraging in our mesocarnivores, with cascading benefits for the small mammal prey further down the food chain, who were just so happy that the carnivores were now cowering in corners. Demonstrating that fear of humans does have landscape scale impacts that go at least from mountain lions down to mice. Okay, so clearly some wildlife are fearful of humans, and I've just shown you that it can carry some ecological consequences. So we may want to know then, well, on the planet, like, how scary are we humans? Well, to find out, we've been conducting a series of comparable experiments across the globe using our ABR system specifically. And all of these experiments are designed to test the reactions to playbacks of humans speaking calmly in locally used languages versus large carnivore vocalizations versus a non-predator control. Now, for our first, we already know that badgers certainly fear the human super predator most. Then we followed up the cougar study and established that humans, but not their dogs, displace cougars from their kill, such that cougars spend a lot less time feeding at their kills when they hear humans. Dogs have no effect whatsoever. Then we looked at a large herbivore, white-tailed deer in Georgia in the United States, and with our collaborators demonstrated that fear of humans caused deer to flee more than twice as often as any other predator. We did wolf, dog, cougar, coyote, and deer did eat less as a result. And then, so that was all the halcyon days pre-COVID, right? And then COVID hits, and we can't travel anymore, but our ABRs can. So our ABRs took a nice little trip to Sweden, and we worked with our collaborators and did an experiment showing that fear of humans reduced the time deer and moose spend feeding in agricultural crops much more than hearing wolves and dogs.
På kulturskolan där jag jobbar så eleverna utvecklar sin kreativa sida inom På kulturskolan där jag jobbar så eleverna utvecklar sin kreativa sida inom bild, drama och dans tillsammans med engagerade lärare.
Still COVID, and our ABRs took a nice trip to Tasmania, where we worked with our collaborators and have demonstrated now that fear of humans caused marsupials to flee from bait patches more than twice as often as did hearing dogs, wolves, and Tasmanian devils. I'll show you some of that.
G'day, it's Anne here, and if you're looking around here in the on-track podcast feed, hello.
Get back on the boat where I started vomiting and didn't stop for hours. The only upside was when the captain said, actually, fish love them.
Some young people who are taking historic court action against billionaire Clive Palmer and his report.
And then goes back to foraging. And then 2022, COVID's kind of over, so Mike and I get on a plane for our first time in many years, and we worked with our collaborators and did an experiment which is demonstrating that fear of humans causes wolves in Poland's Tukula forest up here to flee significantly more than they do to dogs. And importantly, another thing that this really demonstrates is that expanding wolf populations in Poland have not lost their fear of humans. This is important because some politicians like this guy here and other groups are saying that they have lost their fear and therefore we should kill them again. Well, they haven't. Now, in 2023, we got smart and we said, okay, look, we got to take our ABR somewhere warm where there's beaches, like we live in Canada. And so that's what we did. And we took our ABRs to Florida during, the worst of the Canadian winter. We went along with our student Amadeo Cortese. And here we are finding that Florida mesocarnivores, so this group of animals here, most fear the human super predator. The carnivores flee 2 times more than they do to dogs. Now, another thing that our collection of ABR experiments is telling us is that wildlife really do appear to be recognizing that humans per se are the predator. We are the real danger. Right? Our related disturbances, like our dogs and such, they're just our lesser proxies, right? Because for all of these ABR experiments, we have always used dogs. And we've done that because we thought that dogs would be a fantastic positive control. Surely everything's going to be afraid of a dog, right? Well, they're not really. Because what we consistently find is that fear of humans really far exceeds that of dogs, our associated killing technology that humans developed, indicating that indeed wildlife appear to recognize that humans are the real threat, the real predator. Now for our last ABR experiment, we just did a massive one. It led to over 10,000 videos, over 4,000 independent trials. And here with our collaborators, we're looking to see whether or not fear of the human super predator could pervade an entire savanna mammal community, from elephants all the way down to the smallest little, weeest little diker. We did this in Kruger. And what we find is that considering the community as a whole, wildlife run 2 times more from humans than they do to lions. Now, when we think about what this actually means, it indicates that we are more frightening than this, right? The world's most fearsome large carnivore, where it is most abundant. Kruger having one of the largest lion populations left in the world. Fear of lions should be maximal here, but we were 2 times more frightening. We further showed that responses to hunting sounds, so our killing technology, gunshots and dogs again, were similar to lions. And finally, another key result is that as a whole, wildlife abandoned water holes during the dry season where the ABRs were set up in about 40% faster time when they hurt humans compared to lions. And again, gunshots and dogs were similar to lions. So looking across species then, we see that 95% of species either ran more from humans versus lions, or abandoned water holes faster from humans than lions, indicating that greater fear of humans than lions is overwhelmingly pervasive in our savanna mammal community. And I'll show you a few examples of what fear of the super predator looks like.
Because we have 11 official languages, English is that one. Women's World Cup to be held in England.
I don't know that I started loving the law. I think there were things.
My dad was a teacher, so I grew up in a home that everything I knew was sport. I played tennis, I played cricket.
Now, the one exception here with running are elephants, because elephants significantly ran more after hearing lions than they did to humans. And what we discovered, though, is that elephants are not actually running away from lions. They are actually running toward lions. Right? So those elephants were out to annihilate those lions, just like it annihilated our camera there, right? And importantly, they never did anything remotely like this when they hurt humans. They always, always, always retreated. And indeed, when we look at time to abandon the water hole, even elephants most feared the human super predator. And so now, all in all, we have growing experimental evidence that this paramount fear of the human super predator does appear to pervade the planet. And we think that the relevance of this is really kind of twofold. The first is that if we come back to one of the first questions I asked, right? How to manipulate fear in free living wildlife to get at our population community answers. Well, we think that we have this question pretty well nailed. Right? We've successfully used large-scale, long-term predator vocalization playbacks to demonstrate that fear itself can have effects on populations and lead to trophic cascades. But now, what we might need to start thinking more deeply about is, what fear should we be manipulating here? And have we perhaps been looking for fear of all the wrong predators? For example, in this paper, recent paper, it's a review paper by Rob Pringle and colleagues, they say very large herbivores are less vulnerable to non-human predators and thus less behaviorally sensitive to risk. And they say the irrelevance of this is that this is perhaps why we don't always see trophic cascades in large carnivore, large herbivore systems, right? Because of this lack of behavioral sensitivity to risk. Well, what we suggest is that, well, the reason for that is because we have indeed been focusing on this and not on that, right? And maybe we need to rephrase this a little bit and think about medium, large, and very large herbivores and carnivores are more vulnerable to human predators and thus are more behaviorally sensitive to risk from humans. And if this is the case, then it makes sense that to make further progress, experimentally testing our population and community impacts of fear on anything, large enough to fit on a dinner plate, then we must be testing fear of the human super predator. It is that predator that is going to give us the best resolution when it comes to how fear functions in nature. Now, the second thing is that knowing that wildlife fear humans, we're very interested in seeing whether we could use fear of humans as a conservation tool. I've already told you about one of these experiments. So I've already shown you that fear of humans turns feeding on crops to fleeing from crops, and so this reduces crop damage. That was the purpose of the experiment. We have other ones on the go. I'll just tell you about another one. Now here, we're interested in looking at whether we can scare predators with human predators to protect shorebird nests. And we're doing this with the Florida Fish and Wildlife Commission, along with our student Amadeo. Now, global shorebird population declines are largely these days driven by nest predation, mainly by mesocarnivores. And the same is true in this area of Florida where we work, where this variety of shorebirds has to contend with this variety of mesocarnivores. And so the idea here is to play the human super predator to see whether or not this can reduce mesocarnivore foraging and so increase shorebird reproduction. Well, the way it works is that the shorebirds nest on these long, skinny beaches here. The mesocarnivores live here. So at these sort of pinch points, we set up speakers. They play either humans talking or frogs peeping. This goes over an entire breeding season. The idea being to see whether we can turn intruding predators here into retreating predators when human sounds are being broadcast, thereby improving offspring production for shorebirds and hopefully population numbers too. So that's our work on the ecology of fear. And we think that these sorts of effects that I've been describing today are going to be universal across all animal taxa, simply because all animals have to respond to predators. You have no choice. And predator-prey interactions have always been a powerful evolutionary force that has always shaped all life on our planet. This is very well established. What is not so well established, though, is how fear effects operate over ecological time. We are just beginning. This in itself is just beginning to become better appreciated as a basic fundamental principle in ecology, which we hope will also make the textbook soon. That would be great. Well, I want to thank you all for coming out today, and I want to thank our various students. This is just a handful of the more recent one, our wonderful collaborators as well. And I will leave you here with an iconic large carnivore predator, which don't look very scary here, but they really are. Thank you.
All right, are there any questions?
Yeah. Do you want to do that? Do you want to ask, or do you want me to point, or?
You can choose.
Okay.
I have a couple questions. Thank you for the talk. This was amazing and really great to see the videos and all of it in action. One of the first questions that I had was, did you try to introduce any novel noises? So you have humans talking could there potentially be the idea that some of these predators are pretty solitary and live in areas that are less human populated, so just like the novelty of the human noise might be something that scares them off?
Yeah, I think Gio and I were talking about this. Yeah, people always have the impression that, animals don't, that they're not familiar with humans. And that's totally not the case, right? Like 8 billion humans, we're in every single nook and cranny, and we're everywhere. We are not novel. We have, and in South Africa, we've been there for millennia, right? This is where humans evolved. And so humans are not novel. And the other thing is that we have done novel sounds before, and we find that animals don't care. There's also been a review paper. It was Hatena and Blumstein that looked at, it was something like 182 playback experiments on birds and mammals. And what people consistently find, interestingly, is that animals don't care about novel sounds. It's kind of cool, but they don't. It's a great question. Did you have a second one? Did you want to ask your second?
That was a quick follow-up. That kind of, the elephants kind of answered it for me. But I was curious if you have any instances where like an animal would charge the camera, like a predatory animal has a territory set up, here's another predator in it, if it would try to attack your camera.
We have not seen that. We have not seen that. But that's a great question because hyenas, for example, they have this love-hate relationship with lions, right? Because lions hate them, so they would kill them. But then hyenas scavenge their food. And, but yeah, I should have a look at that. I have not noticed any more approaching from of hyenas to lions or retreating. I'll have another look at that. That's good. That's a good question. Thank you. Yeah.
I'm curious if you noticed any differences with like the intensity of the sound or quality of the human noise, or I guess like how close the animal was to the speaker, and because the response was greater, or the startle response was more when it was like an intense like start, I guess, of the sound versus like maybe more diffuse.
Right. Yeah. I mean, that's why we do a control, right? To control for any sort of startle, because the only reason they would run to a bird is if they got startled by the sound. So that all controls some things. But in terms of other kinds of controls, that's all about our experimental design, right? So the sounds are such that they're the same length of time and they're the same volume. So they're broadcast so that it's about 60 decibels. So how I sound like this is how it sounds to the animals when they're 10 meters away. And and we too wondered about that, whether or not distance would make a difference. And so we have done an analysis where we looked at 5 meters from the speaker. And I should say too that the other thing is that for all of the experiments, we don't want the animals too close for that very reason. And so we do pile up a bunch of crap in front of the camera so that the animals can't get too close. And it's piled up for about 5 meters, so they can go about 5 meters. And so we have looked at 5 meter distances, 10, 15, 20, and greater than that. And we've just done it on the Impala, which is one we have the most data on, and they show a huge response to humans. We don't find any differences. So it'd be cool to look at other species as well, but at least for the Impala, nothing. Yeah.
Great talk. I was curious, kind of like following up with this idea of fear of humans as a conservation tool. You were kind of showing how we can protect like shorebirds. I'm also wondering if there's any thoughts or ideas of like using that like to re-affect like trophic cascades in a way that will maybe like go back to like a time when there's like maybe like more predators around, and we can like scare some of like these smaller carnivores or herbivores so that like their populations might decrease, and we might kind of see like a change in the landscape that was like a more less degraded ecosystem.
A less degraded one.
Yeah, if there's like any ideas of using it that way, possibly.
Not certain I totally understand what you're saying, but you know, in terms of affecting things like reproduction and survival and things like that, you know, that all depends on the length of time you can do these kinds of experiments before the animals do become habituated, right? And so you know, we've done a variety of things, right? So like the birds, we did 4 months at a time, not habituated. For other things like cougars, 5 weeks, mesocarnivores, 4 weeks. And so we know we can run them that long. And so if we wanted to impact reproduction using that, then that's really the key, right? Making sure that you get things at a critical time, like during breeding or whatever, and make sure that, you know, and then measure the responses to reproduction and whatnot, and make sure that they don't become habituated. Does that sort of answer your question?
Yeah, thanks.
Okay. Yeah.
I'm glad you got that up, because one of my questions about habituation with animals. So like, if you ever see, I guess, a seasonal change in how prey may react to humans, because I was thinking about like Yellowstone National Park, where there are like the elk that are just like running around next to all the cars or whatnot, and they seem almost habituated to people. But they wouldn't find them to be as predators, versus outside the park, they're like hunters or whatnot. So do you know if there's been any studies to look at if there's a change in perception over time?
Yeah, you know, I think a lot about this, and because, you know, I myself see the same thing, right? So like I go to some places in Kruger where there's a lot of ecotourists, and I'll come back to this because I actually have some data. And the animals there, they look like they do not care about people. And you go outside of Kruger, where we did the experiment, the super predator experiment, they're 2 times more afraid of people. And you can sort of see it, because when you go there, you can't get close to them, right? It's really annoying if you're trying to take pictures, right? And so, and it's like this, right? Like mesocarnivores live with us. Surely they love us. Well, they don't. And, you know, and animals look, like I was trying to explain at the beginning, they don't really look afraid, right? Like you can't see it in their eyes, right? You got to do the experimental test. And so I've never really come across a situation, and can't imagine one, where an animal is truly habituated. They may be more tolerant of humans or not, depending on the situation, but habituated, not so much, maybe in a domesticated sort of sense. And, you know, we've done all these different experiments, you know, they're really varied, right? Like in Kruger, this place, just outside of Kruger, they're afraid of people, but, you know, like it's kind of a protected area. We go to Georgia in the United States. It's a reserve. Only researchers are allowed there, but they do kill the deer. You know, it doesn't really seem to matter what the context is. We typically find that animals are 2 times more frightening to humans than they are to other things. And then coming back, let me just show you here. So last year what we did, so this speaks to your question too. So last year what we did is we went, because it's a puzzle, right? Like it's this crazy puzzle. What's going on? And so, so we went back to South Africa last year, and we did a manipulation to sort of test just that. And so we did broadcasts of humans and lions. Here, that was the current biology paper, the super predator paper I talked about, where they're 2 times more afraid of humans than lions. And we also then did this in Kruger Park itself, where it is absolutely chock-a-block with people, but they're non-lethal. They're out there driving around looking for the animals, and truly, the animals do not look afraid. They come right up to you, right up to the cars. People do vehicles, right? Like you're not allowed to go out because like the lions can eat you, right? And so, so this is what it looks like. This is a picture that I took in Kruger because this lion was on the road, and like there's tons of people. So what is going on here? Surely these animals are not afraid of us. They do not look afraid of us. And, you know, for parks, it's really important too, because South Africa national parks, the way they operate, like most of Africa, right? Like you can't rely on a tax base because people just don't have money. So there's not a lot of taxes like we have in North America to run parks. They rely on people going through the gate. They operate on gate receipts. Without that, they're doomed. And so they need a lot of tourists, and tourists need to go there because otherwise the poachers will come in and they'll just be a disaster. And so, so that's one thing. That's what they need. But the other thing is that, they are charged with protecting these species and making sure that they're doing well. And they know about our research. And so, they're thinking, well, if the animals are really afraid of people, then I don't know, maybe we shouldn't do tourism because maybe this is having all kinds of cascading effects, reducing the reproduction and such, just people walking around. So it's a really important question. So that's what we were testing. We were working with sand parks and we're testing that. So we did humans and lions in these two areas. I'm sorry, this is such a long answer. and we also did, instead of, we did lethal hunting sounds before, gunshots and dogs. This time we did tourist sounds. We did engines and engines with people in them. And so these are the treatments here and our two sites. And this is kind of what we're finding. So this is this little icon. This is the Sand Parks icon. So this is where there's few tourists. And this is kind of like abandoning the water hole. Okay, so if they abandon faster, they're more afraid. And one of the key things here that we're sort of finding is that it doesn't matter where you are, right? So it doesn't matter if you're in the area where we worked before or in this place that's full of eco-tourists. Animals are still 2 times more afraid of humans than they are of lions. So if we compare the sand parks, Kruger here, and the place where we worked before, same thing, right? But it does look like their responses may be a bit attenuated because if we look at engines and with humans in them, you can see where we were previously, they're still scared shitless of people, right? So even though they're in an engine, there's an engine plus people, they are queuing in, person gone. But what might be a good story, I don't know yet, is that that engines kind of seem to mask the fact that humans are in there a little bit in Kruger, which might be really good. Might be great for tourism, right? That they're doing that kind of tourism is okay. Like it's scaring the animals, but they're not like off the scale scared. So yeah, apologies. Yeah.
That's a really cool topic. It's very interesting. Thanks. I have a couple things that are sort of related. But the first question I have is that, so the PTSD model of having a scary reaction that seems like threatening results with your response totally makes sense. So I'm wondering why the human voice, like a normal talking voice, which seems, I may be wrong, but it seems pretty unlikely that so many species have had that type of experience with a normal human voice. So why do you think that the signal is so strong in response to that, even compared to something that they would have a really clear association with? Like a lion or a wolf or something like that.
Well, this is kind of like I think it's sort of like your question, isn't it? It's about animals know who their predators are. They are telling us who the predators are, right? So it's not like they don't have any experience. One reason so many animals have gone extinct or are in decline is because humans friggin' kill them. Right? So animals, all kinds of animals, not just, the pet trade, right? What pet trade, you go in, you grab some birds. That's like a predation event. one reason a lot of birds have gone extinct or are tanking because of the pet trade, right? So humans do all kinds of stuff like that. There is no way there is an animal that has not been exposed to humans and our lethality. It was suggested to me once that maybe there's a part of Antarctica, maybe, I don't know, I haven't really thought about that too much, but, and the other thing is that we've been doing this for millennia, right? So let me see, I think I have another, right? So this is just some thoughts on why, and we're writing a paper on this. So, and so this is just some thoughts on why humans are so feared. We are a significant predator, right? But when you think about, like, group hunters are really formidable predators. And when you look around the world, and the larger you're going to be, the more scary you're going to be, right? The more devastating you're going to be. And so when we look around the world, it's really cool that lions are certainly the largest group hunter on the planet. Humans happen to be next. We are huge. We are a huge mammal, group hunting mammal, and because we're group hunters, we are deadly. And the other thing is that we are the world's only predator that can kill something as vast, as massive, as frightening. People think that elephants are cute, like Dumbo. They are freaking scary, I tell you. And humans are the only thing that can kill adult elephants. And this has been true for millennia. This is from 28,000 before present. This is elephant hunting on a petroglyph from 8,000 years ago. And thirdly, we have been around forever, right? For a really long time. And we are large human societies. We have various bits of killing technology, right? Like, we can throw stuff, right? That makes us deadly because we can throw rocks, we can throw spears, we have dogs. This has been the case for thousands and thousands of years. So, for example, this is a drawing. It's an Egyptian pharaoh, and he's taking a spear, and he's trying to spear this lion here with his dog 3,100 years ago. Even in Aesop's fables from 2,500 years ago, it's stated, "See how we prevail over the king of beasts." And this is a North African elephant, extinct 1,600 years ago. Why? Because the Romans hunted them to extinction. And here, and we've been all over the world, right? So large human societies have been, with this, sophisticated killing technology, has been all over the world. This is just an example of the Maya from 1,200 years ago, right? So, humans novel? No, I would say not. I'm giving really long answers. I'm sorry. Yeah, go ahead.
Okay. The second thing I wanted to ask about was using running away versus freezing as an indicator of your response. I thought the chickadee example you had was really neat, and so I was wondering if that's an example of they've been primed and they're afraid, but they were more likely to stay still instead of running away when they were primed to be scared. If that's different in mammals, because if the videos that you have are like they're running away from humans as a response to fear, I was just wondering if it's different between birds and animals, or if the freezing response that you see to like a lion could be similar to what you saw with the chicken.
Yeah, so, I did my master's on this, but so chickadees, they have the two kinds of responses, right? So they have the response where they will freeze when they hear the high Z call. And that is the call that we play to those chickadees. But when they hear a mobbing call, chickadee mobbing call, that everybody comes in, right? Tries to kick the crap out of the predator. So we actually use the high Z call in that circumstance, and chickadees do flee. Like if you have them at a feeder, you throw something over it, they flee, right? But one example I can think of is that dikers are wee small ungulates, and they're mostly nocturnal, and dikers do mostly freeze. They often do freeze. They sort of go behind trees, and they hope that nobody sees them, and they stop. And so for that one, we did actually see, that was the one species where we saw a difference between day and night, because if they were out during the day, they would run. If they were out at night, they would hide behind the trees. They had a different strategy, but we didn't actually see that in anything else.
All right, well, I think we're about out of time, but if anybody has more questions, we can hang out in the front area by the coffee and talk some more. Let's thank Liana for her amazing talk and for answering all our questions. Thank you again for coming.